Hi everyone, this is Mrs. Snowbeck and we are starting Unit 4. Unit 4 will be the last unit for this trimester, so yay. We're going to study today polygons, and so you need to kind of know what a polygon is. A polygon is a closed figure and each side intersects exactly two other sides. And the common endpoints are called the vertices. All of the three shapes that you see here would be considered polygons. They are not regular polygons, but they are polygons. So all of them are made out of straight segments. None of them have curves, and all of their segments end exactly at the end points of the next segment. So they don't overlap at all. Here's some examples that are not polygons. A circle is not a polygon. This is not a polygon because it's not closed. A heart is not a polygon because it has curves. And another example would be something like this, where it doesn't end exactly at the endpoints or doesn't meet exactly at the endpoints. None of those are polygons. So there are two types of polygons. There's convex and concave polygons. And the way that I remember is concave polygons cave in. Okay, so for instance, up here at the top, you can see this kind of caves in a little bit. Another mathematical way to tell if something is convex or concave is if you pick 2 points in it, no matter which 2 points you pick, if you connect them and it stays inside the shape, that is considered convex. But if there's a place where you can pick 2 points and the segment connecting them goes outside of the shape, then it's concave. And you can see some more examples of convex and concave. I just always remember concave caves in. So let's talk about all the different types of polygons. The first one you know really well. A 3-sided polygon is called a triangle. And we've studied triangles quite a bit this year. Think about what's 4-sided. A lot of people think square or rectangle, but the actual term for all 4-sided figures is quadrilateral. Quadrilateral. Quad means 4. Next we have pentagon. So 5 sides is called a pentagon. Maybe you've traveled to Washington, D.C. and you've visited the Pentagon. It's actually a building that looks like a pentagon. And inside of it, there is a courtyard in the middle that's also the shape of a pentagon. 6-sided polygon. A 6-sided polygon is called a hexagon. The way that I remember that one is I think about like a hex has an X, and then 6, the word, also has an X. So hex and 6 both have X's. Next we have 7 sides, and 7-sided polygon is called a heptagon. Heptagon. 8 sides, this one you probably know. It's an octagon, like a stop sign. An octopus has 8 legs, an octagon has 8 sides. Next we have 9, and a 9-sided polygon is actually called a nonagon. Not nineagon, but nonagon. 10. So a 10-sided polygon, you might know this one too. It's a decagon. I think about 10 years. 10 years is a decade, and 10 sides is a decagon. So dec means 10. Then we have 12. So 12 is a dodecagon. Dodecagon. And for some of you, I think of 12 and I think of a dozen, and D-O starts like the word dozen with D-O. Another way that you can think of it, if you're a person who takes a language or you speak another language, for instance, Spanish, you can think of this in the terms of like Latin roots. Dec is kind of like 10 or diez or decagon, and dos is 2, so it's 10 and 2, so 10 and 2 is 12. Next, 13. 13 and beyond, we just call a 13-gon, a 14-gon, a 15-gon. And you can also do that with 11. You can say 11-gon. So however many sides it has, we'll just say n number of sides, you can call it an n-gon. If it has 101 sides, then it's a 101-gon. So the first figure that we see here is a triangle, and this triangle has 3 sides. And the sum of the interior angles, so in other words, if I add up this angle and this angle and this angle, if I add all of those up, they will add up to 180 degrees. So think of it as 1 times 180, which is 180. Next, we have a quadrilateral. It has 4 sides. So think of it in terms of dividing it into non-overlapping triangles. Like right here, I can divide it into 2 triangles. So each of the triangles is 180 degrees, so I have 2 180-degree triangles. Well, 2 times 180 is 360 degrees. Next, we have a pentagon. It has 5 sides. If I break it up into non-overlapping triangles, I have 3 triangles. You can see 1, 2, 3. 3, and they're each 180 degrees in every triangle. And 3 times 180 is 540 degrees. So think about that. If I take all of these angles inside of the pentagon and add them up, it's going to add up to 540. Next, let's do the hexagon. So a hexagon has 6 sides. If I divide it into triangles, there's going to be 1, 2, 3, 4 triangles. 4 triangles. Each triangle is 180 degrees. That is 720 degrees total. So the angles inside of here, if I add up all 6 of these angles, it would add up to 720 degrees. So what if I have an n-gon? How many sides does that thing have? Well, we don't really know, but it has n number of sides. So look at the pattern here. At the top, we saw that when we had 3 sides, it was 1 triangle. When we had 4 sides, it was 2 triangles. 5 sides, it was 3 triangles. So it kept going always down by 2, correct? It was always 2 less triangles. So when you have an n-gon, it's going to be the number of sides minus 2. That's going to tell you how many triangles fit in it. And then you multiply that by 180. And that's how you calculate the sum of the interior angles, what they all add up to. Now the second column here that we're going to fill out, it's called the measure of an interior angle. So we want to figure out, well, how big would one interior angle be? Well, in a triangle, there's 100 degrees. If it's a regular triangle, that means all 3 angles will be the same size. So divide it by 3. You end up with 60. So each of the angles inside of a triangle would be 60 degrees if they're all the same size. In a quadrilateral, you have to take the 360 and divide it into 4 parts. That's 90 degrees. So in other words, if you have a quadrilateral, which we know ends up with a sum of 360 degrees, the angles in there add up to 360. If you divide it into 4 equal parts, each of them would be 90. Now remember, in a pentagon, they add up to 540. So we're going to take 540 and divide it by the number of angles. So how many angles do we have in a pentagon? Well, we have 5. So 540 divided by 5, if you type it in your calculator, it's 108 degrees. So each angle inside of here is 108 degrees, but altogether they add up to 540. Next, we have a hexagon. So take the 720, and if you want to figure out how big one angle is, divide it by 6. That's only if it's a regular hexagon, only if they're all the same size angle. So 720 divided by 6 is 120. So each of those angles is 120. So last but not least, what if we have an n-gon? Well, you take the sum, which was n minus 2 times 180, and you divide it by the number of sides. Whew, that's a lot of info. So here's what the homework will look like. Number 1, what is the sum of the interior angles of a heptagon? Try to think back, what was a heptagon? If you're thinking 7, you're right. So remember, this is where we're going to use n minus 2 times 180. We want the sum of all the angles. Heptagon is 7, so we do 7 minus 2 times 180. 7 sides. That means we're going to have 5 triangles. So 5 times 180. And 5 times 180 is 900 degrees. That would be the sum of all the angles in a 7-sided figure, or heptagon. Next, we have an 18gon. So we do 18 minus 2 times 180, which is really 16 times 180. And then you're going to have to grab your calculator and type in 16 times 180. And when I did it, I got 2,880 degrees. That's a lot of degrees. Okay, try part C. Go ahead and pause the video and try part C. Dodecagon is 12, so 12 minus 2 times 180 is 10 times 180, which is 1,800 or 1,800 degrees. Number 2, now we want to find what is the measure of each interior angle. So we don't want to know what they all add up to. We want to know how big is one of them if it's a regular heptagon, regular octagon, etc. Well, remember from the previous page when we did 7 minus 2 times 180, 5 times 180, it was 900. So altogether they add up to 900 degrees. And then if there's 7 angles inside of there, we have to divide it by 7. 900 degrees divided by 7 angles is kind of a weird answer. It's 128.57 degrees. So you actually get a decimal. So in that 7-sided figure, each angle in there was 128.57. Now remember, in the 18gon, remember what we did right up above. We had 18 minus 2 times 180, and we got, I'll just write it out again. 18 minus 2 times 180 is 16 times 180, which was 2880. That's the sum of all the angles. You don't really have to copy that part down. But what you're going to do is take that 2880 and divide it into 18 parts. And you're going to figure out how big is each angle in there. So 160 is what you should get. So try part C on your own. Pause the video, try part C. So remember, the sum of all the angles of a dodecagon was 1,800. So we have to take 1,800, and dodecagon is 12, so divide it into 12 parts. And when we do that, we get 150. So 150 degrees is the size of each angle in a dodecagon. Number 3, how many sides does this have? Well, it has 1, 2, 3, 4. 4 sides, right? So it's a quadrilateral. So think about 4 sides. 4 minus 2 times 180. That's really 2 times 180, which is 360. So inside of this quadrilateral, the 4 angles add up to 360. However, they are not all the same size. It's not a regular quadrilateral. But I can make an equation. I can say 3x plus x plus 90 plus 90 have to add up to 360. all four corners, A, B, C, D. If you add up all four corners, it should add up to 360. So we have 4x plus 180 equals 360. Combining like terms. Minus your 180. 4x equals 180. Divide by 4. X equals 45. So x is 45. Now we have to find the measure of angle A. So we're going to have to take that 45 and we're going to have to bring it and plug it in for A. So it's going to be 3 times 45. So grab your calculators, type that in, and I think it turns out to be 135 degrees. And then lastly, we need angle B. Well, angle B has one of those little boxes in it, so that one is just 90 degrees. All right, last question, question number 4. How many sides does this have? If you're saying 5 sides, you're going to do 5 minus 2 times 180, which is 3 times 180, which is 540. So all of these corners, J, K, L, M, H, all of them together should add up to 540. So combine all your like terms. I have 3x, that makes 6x. Here's 2 more, here's 2 more. So I think that's 10x. See what you think. 3 plus 3 plus 2 plus 2. Yeah, that's 10. So we have 10 x's. Then we have a 14, a 142, and a 14. So you have to add up 14, 142, 14. Add up all those constants. And when I did that, I got 170. And all together, we said it has to equal 540. Remember, we said that over here. Notice I took a little bit of a shortcut. I didn't write out the whole long equation. Instead, I kind of combined them first instead of writing out every little piece. I combined my like terms. Now we're going to subtract 170. So we have 10x equals, if you punch in 540 minus 170, you should get 370. Divide by 10. X equals 37. Are we done? We are. All right, so that is the end of the notes for Unit 4, Lesson 1. Now will you guys try Unit 4 Practice 1, and when you're done, go ahead and drop it into Schoology. If you have questions, be sure to send me a Schoology message. Have a great day.